everyone, and welcome to another edition of Launchpad Office Hours. This is number 18, and today is 5th of June 2024. So today on the agenda, we will, as always, update you on the latest Launchpad development since last LOH. And today we have prepared for you FedoraCoreOS overview and a small demo. And this is specifically because FedoraCoreOS is quite suited for running Kubernetes as operating system. And you'll see why in a bit. Okay, so some of the updates since last time we spoke to you. Launchpad chats have had new versions of Subgraph Radio, Aragon, Nimbus, GraphNode, Arbitrum Nitro, and very important Heimdall. So Heimdall is now up to date with the latest version on Launchpad charts. And on Launchpad namespaces, we have had stable releases of the monitoring namespace, the Postgres operator namespace, still secret storage, Ingress, Graph, Ethereum, Cello, Gnosis, Arbitrum, and again, very important, we've added Polygon support in our namespaces. And in terms of docs, we haven't had any new changes to docs, but we are still reviewing them for improvement, and more changes will come very soon. And as always, the links to the issues. Okay, so talking about FedoraCoreOS. So this is an operating system that integrates Fedora's stability and robustness with some of CoreOS advanced and container-centric architecture to deliver a scalable and very secure platform for cloud-native applications. We are running. This is an operating system that is quite well suited for running self-managed Kubernetes clusters, and this is the additional context as to why we're covering this today. We are running it ourselves. Some of the features and the benefits of it. So FedoraCoreOS is automatically updated, which ensures the latest security patches and features. This is done with an agent called Zincati, which is enabled by default. It has a minimal footprint, making it lightweight and efficient. You could look at it as a monolithic system in the sense that it provides a solution to run containers and all of the system services out of the box with components such as Ignition for configuration, Zincati for automated updates and rollbacks, and Podman for container operations. And it is container optimized, and it's also designed for clusters, but also operable standalone. In terms of architecture and design, it follows the CoreOS architecture, which focuses on minimalism and performance. It has a strong emphasis on security by enabling by default the SE Linux module. It has read-only root file system, or mostly read-only root file system. It allows for updates and rollbacks, and additionally has cryptographic integrity verification. It also follows the immutable infrastructure concept, which prevents configuration drift and enhances reliability. So if you are to compare it to a traditional Linux distribution, so a traditional distribution is mutable, and although most distributions will offer some mechanism for automatic updates, they are not enabled by default. And as far as I know, they don't support rollbacks easily or without user intervention. Comparatively, CoreOS has the immutable system managed through OS3, which provides a Git-like update mechanism. It has Zincati for updates. The updates are version controlled, which enable easy rollbacks, and that will become very apparent in our demo today. And the system's design reduces the attack surface via the security features we've already mentioned. Okay, so when we talk about these components, we're talking about OS3 and RPM OS3, which are version file system tree with transactional updates. So updates either happen successfully or they don't at all. Then we have Ignition, which is the configuration tool that allows for initial setup and configuration. This follows the infrastructure as code setup to ensure consistent and repeatable deployments. We have systemd for managing system the box for container management, and Zincati as well. When we talk about configuration with Ignition, so it uses JSON for configuration, and its structure contains a version which specifies its version, storage to define file systems, files, directories, and links to be created, systemd section for defining systemd units, networkd for defining network units, and password for managing users and group. Additionally, if you don't like writing JSON, there is an additional tool called Butane, which is specifically created to simplify writing Ignition configs. You do this by writing your configuration in YAML, and then Butane would convert it into a Ignition JSON format. On provisioning, so there is a tool called CoreOS installer, which deploys FedoraCoreOS onto a disk using the CoreOS installer CLI. Then in terms of the dynamic nature of the configuration, so we said that the root disk is read-only except for the etc and var folders, which can be used for dynamic configuration. And when it comes to upgrading and rebracing, you would use the RPM OS3 tool for upgrading and rebasing to newer base images. You can also reset all mutations with RPM OS3 reset. And you can change to a different base image with RPM OS3 rebase. Okay, let me see where we are, because so I think before we talk about RPM OS3, I'm gonna start the demo because it takes a few minutes for the image to, for the instance to provision. So the demo today will just use a very tiny AWS instance, and I have okay. So we talked about how we use Ignition or Butane. So this is a Butane file that specify password with the user and with the authorized key, specify some file, some networking and file system configuration for the system, some the number of file limits for the system, and enabling some kernel modules. Some of these are basically I've included because they are useful in a containerized application, but also Arbitrum was one of the workloads that really required really high file system limits. And then we also have this message of the day to welcome us to FedoraCoreOS. This is all this task in addition to installing FedoraCoreOS, so that's what we're going to use. So this is a Butane file. We are going to transform it into an Ignition file, and basically using the butane that's installed on my system, and I'm just gonna copy it. So going here, starting a new instance. I'm gonna call it FCOS demo. We're gonna get one of the FedoraCoreOS AMI that already exists in AWS. I'm gonna use this one, the 38.2023. It is a stable version. It's not the latest version by any means, but it would give us an opportunity to see how Zincati updates versions. And then I'm just gonna give it a key pair. I'm not gonna mess with the network system. I'm just gonna leave all of that as default. And I'm going to give it user data, which is my ignition file. Now, if you're to deploy this with, to install this using, let's say, like Hetzner servers, you do this in the rescue system, and then you would use the CoreOS installer CLI. But here I'm just giving it the image and the ignition file, which is what I copied from here. Launch instance. Checking chat. ChatGPT indeed prefers YAML as well, probably more readable. Okay, while this starts, okay, it's pending. We'll continue with the presentation. Okay, so we've mentioned RPMOS 3. This combines libOS3 as the base image format and accepts RPM on both the client and the server side, and it shares code with DNF. So DNF is the dandified YAM, which is the next generation of YAM, the package manager for RPM-based Linux distributions. So some of the benefits of RPMOS 3 are that it allows for atomic updates. So updates to the base system image are applied atomically, reducing the risk of a broken system state. We have the rollback capabilities, which are provided to us by libOS 3. We have package flexibility. So while the base system is managed as an image, RPMOS 3 allows for additional RPM packages to be layered on top. And then we can also control style arguments transactionally using RPMOS 3 KArgs and RPMOS 3 init ramfs. And by sharing the code base with the DNF project, RPMOS 3 benefits from a very mature and well-tested package management infrastructure. Some additional things around RPMOS 3. We talked about how it allows you to control both init ramfs and kernel arguments. Something to note is that the bootloader does not get upgraded by Zincati, but there is a tool that allows you to do that, so bootupd. And FCOS is designed to run containerized workloads, but you would ideally run containers over layering additional software as much as possible. And keep in mind that upgrading the base image requires a reboot. SE Linux is enabled by default, as mentioned, which is great for security, but it creates a harder barrier to entry. So if you need help with creating SE Linux policy, you are invited to use something like Udicam, which is a tool for generating SE/Linux security profiles for containers. Okay. We'll briefly talk about CoreOS layering, and then we can go into the image. So FedoraCoreOS leverages the CoreOS layering, which allows us to manage a node's disk image as you would do with containers. And here's an example of an image that looks very similar as a container image. It starts from FedoraCoreOS stable, and it installs like Kubernetes components in addition to the base layer. For more details on this, you have this CoreOS layering example where you can see different containers that derive from FedoraCoreOS. We will also run a rebased with one of the layering examples so you can see how that plays out as well. So let's see this. Okay, so it's running. Let's SSH into it. Okay. We have a connection refused, so we're gonna look into system log.
Maybe try again, Anna. Maybe it was just still provisioning.
Oh, there you go. Okay, so you can see the message of the day, and then if we run RPM OS3 status. So I think the reason why it was taking so long was because this is the image we've selected, the 38.2023. In the meantime, as we're speaking, Zincati has already upgraded to a newer image, so you can see on deployments that were on this image. You can also see the configuration of Zincati here. So all of its details. Okay, and as we're speaking, we have a new message from Zincati saying that there's a new update. So we are currently on 2024-01. So there's a 2024-04 update and has been deployed. We would need to log out in order for it to deploy it, but we won't do that just now. Okay. One thing we mentioned was that the bootloader is not updated by default. So if we are to check the status of the bootloader, you can see that the image it's running on is 38.2023. We can update the bootloader. I think it's bootloader up. Let me check. update. Loader update. Okay, so this updated to so updated the grab, but would need to do a reboot in order to see that happen. So I'll do a quick reboot. And I think as I do this reboot, it will also pick up the new Zincati upgrade as well. Okay, while we wait for the reboot, are there any questions? Um, so I didn't give it a policy already. So in terms of how does Zincati know how to do updates, I didn't give it a policy and I haven't layered anything yet. So all you're seeing now is what it comes with by default. So this is the only configuration it has. So it would be following the upstream, the FedoraCoreOS upstream. But yeah, I didn't give it any configuration. And yes, if you're running Pixie boot install, then all the manual steps would be automated, and you would do that via Ignition or Butane. In terms of what types of updates require a reboot and which are applied at runtime, so so this like bootloader update would require a reboot to take place. An RPM OS rebase would require a reboot as well. Although I'm not 100% sure why it didn't apply here.
Well, I think that was the EFI update. So like I think the version number that goes up is not the CoreOS LF version. It's the component EFI version.
Yeah, yes, I think you're right. It's just I remember last time I did this that it was showing on the component EFI the version of the FedoraCoreOS. The Aleph version doesn't upgrade. You're right. But
yeah,
yes, I can see here that no components are adoptable. Sorry.
No, all good. A part of why I asked the question about which updates is because of that broadcast message that like is at the top of the terminal, where like it's found some new image like 39.2404, and it's like at least that message would indicate that it needs to like terminate all user space processes in order to apply the update, or it needs to reboot, or
Yes, so I did do a reboot, so that's why. But I think maybe it expects a system. I think it's system till reboot.
To answer your question, Matthew, like FedoraCoreOS is most attractive if you want to run like 100 nodes than a single node, right? And like when you asked about DXE booting and Vincati, at that point you kind of expected to self-host Vincati, which gives you even more power about that kind of policy because Vincati's role is not just like a central hub to broadcast what new version there is. It also needs to take charge of doing stage upload, like rollout of new versions, because if you have 100 nodes and there's a new image, you don't want all of them updating at the same time and rebooting at the same time, right? You want that kind of control of, oh no, you're gonna install one per day or one per hour, and you're gonna suspend installing updates if one of them like stops booting or something like that. So yes, at that point you're expected to self-host Linkadi, and both on the client end, you have control over certain policies, and on Linkati's end about how you orchestrate the rollout. And regarding the automation part, yes, when you, I think that's still part of the presentation, so we'll touch more on that. But when you want to extend the base image with more software, because it's pretty minimal, and I imagine a lot of people will layer some additional software on top. So they're probably gonna make a Docker file and they're gonna layer some stuff on top, because not everything is going to be run by containers, right? Like there will be some additions you may want to do at the base OS layer. And there's that level where you're building your own image. So there's less automation if you are like just crafting your own image, you can put things in place. Then there's the whole runtime dynamic thing you may want to set up, like systemd units that on boot just configure some stuff. And yeah, some workloads are going to run as containers. I think between all of the control of those types of flows, it's very automatable. You add to that ignition, which gives you like a declarative way to provision the machine at start. And yes, it's very suitable to build a completely automated flow. Of course, you gotta do like your own kind of like some systemd units and to address your specific use cases or how you want things, but it's very amenable to that.
Okay, so thank you for that, Carlos. In regards to needing to self-hosting Cathy with the updates, we'll see in a moment in what circumstances that's the case. So let's quickly see if this has rebooted. Okay, so there is an RPM package for Grafana, for example. There's one for Prometheus. There are a few for Prometheus as well.
I think Matthew was more targeting not like a monitoring stack like Grafana and Prometheus, but more like exporters, like how to get telemetry out of the node to some central point, which will have like a Prometheus or Grafana and stuff like that. Right, Matthew?
There are some Prometheus Podman exporters in that case. Is that what you mean? Yes, there is a node exporter. So while it updated, it actually did two updates. So it did the 39 20 24 04 07 and the 40, which is the latest one. I will add in terms of like setting up your disks, that can be done also configuratively. With the butane/ignition file. So some other things that would be useful to do here are let's install some packages with RPM OS 3. So RPM OS 3 install. We're gonna bypass drivers. This is needed because of the automatic updates setup. And if we install wget IO top, drivers. Sorry, this is not an option for install. It's I think that's for the rebase. Okay. After we install these packages, there will be another reboot. And then we can also do a rebase. And we can also show a reset where it deletes all of the packages from the system as well. So one case where we use CoreOS layering is FedoraCoreOS doesn't come with great support for ZFS. So for that, we use a layering setup for installing ZFS, which means that that is a use case in which you would have to manage Syncati separately. Do you know any more details, Carlos, about Alexis's setup and how he was finding using FCOS on his laptop?
At the time, he mentioned it was not too much of a fuss. Like it seemed to do what he needed. Not a lot of trouble with it.
Nice.
I remember when I
Awesome.
had a chat to inquire him specifically about the SL Linux issue. Like, given that it's enabled by default, it will have, like there will be a lot of software that I'm sure they didn't have policies for, like desktop-like software. But then we figured out that they basically banned all of that out of scope for SL Linux. So like he wasn't having any trouble with that because it all falls into under like an exclusion kind of thing. So like all of the desktop software is just under an umbrella, a very permissive umbrella for everything.
So you're saying that he didn't disable SE Linux, the desktop software was out of scope for SE Linux.
Yeah, they just have like they're using a targeted profile. So instead of applying for everything, only the ones that have policies are being targeted for being constrained.
That makes sense.
Which would be I think the hardest hurdle in using FedoraCoreOS on a desktop would be if you don't go that way and you just really want like SL Linux for everything, then you have to develop policies for all of that desktop software, and that would be a nightmare.
That makes sense. So we've installed all of these packages. Let me see.
Let
You
me
can
just
see that.
let me
Sorry,
just
go ahead.
can you put the status there, because I just noticed something interesting, which I think is noteworthy pointing out. Like before this reboot, we had the version 40 as one of the root disks where we were booting, and then the previous one was 39, and now they're both 40 because the top one, which is the one that we booted through now, has like that list of layered packages.
Oh, yes.
So like the fallback boot is the previous one, so now they're both 40. And it always works like this. Like every operation you do, it makes like new commits, and when you reboot, it tries to boot from it, and if it fails, it always falls back to the on its own, like to the previous one. So that's part of the resilience of like rolling back and all of that.
And now if we wanted to, yeah, that's true. So everything you said, but also if there was any doubts, you can also run the commands to see that they are now installed on the system. And if you wanted to reset the system to the previous version without the packages, you can just run rpm-ostree reset with the cache, I think is for all packages. And that should delete all of these layers and instead go back to this previous image.
No, -i is not for all packages. I don't think Reset has that flag. -i will be for you to install with our rpm-ostree install to try to do it in place and not require reboot to have it available.
That makes sense. Thank you. So you run install with a -a, and that will not require a reboot, which would make sense because some of these packages you may not want a reboot, as they're just right.
How does that actually work? Does it attempt to like apply the commit on the current?
It just mounts on top of the root file system, which is read-only anyway. But yeah, it has like all of those layers, and it can do a root remount, right, on the fly. And that's why also it kind of fails if your operation involves removing packages. That it can do. Like when you install something that needs to uninstall some other package, then you run into trouble sometimes. But just simply adding a package, it usually works well. like underneath it does the same thing. It prepares the alternate root system, etc. But it just attempts to, at runtime, like on the fly, transition to it.
Okay, so while we check for while we wait for that to reboot, I have this registry that we currently have from Alexis around ZFS. So you should be able to see here what he did. So following the CoreOS layering examples, this simply builds an image with the ZFS layer. There's a workflow here that picks up all of the new updates and adds new commit to the layer. And the image he's picking up from is here builds ZFS module, which contains this container file. So if we were to install that on our machine, let's see, we would rebase. So RPMOS 3 rebase does need bypass driver, and the registry would be this. And yeah, all of this stuff that we're doing here. So RPMOS 3, installing all of these packages and even rebasing and all of that can be included into your butane or ignition configuration so that it is as repeatable as possible. Before I do a reboot, I'm just gonna do an RPM OS3 status. And okay, so you can see that, so this version, the one that included those packages, was the previous version. Now we're back onto the one without the packages. And it also shows you that there is a next deployment that hasn't yet been applied, which is the CoreOS layering image for ZFS.
So if you now reboot, we should have ZFS available, right?
Yes. So actually, I can just check that we don't. Yeah. Okay. So systemctl root.
One collateral nice thing about this whole layered container images or the root disk is that when you have to download or update, it kind of benefits from the same kind of thing as Docker in general does, which is if it already has some layers that haven't changed, it only downloads the changes, right? Like the changed layers. So sometimes you manage to not have to download this whole like multiple gigabyte image or something like that, in case it's a big one.
Anna, in case you're talking, I think you're muted.
Thank you for that. I was talking. Okay, so I was saying that I guess you saw that I was running ZFS to see that now it is installed, that the image is on this deployment on the newest base image with the unverified registry. And yeah, there's no zpools installed because we didn't do that. But compared to the previous one, now we have ZFS installed. Then the next thing I said was, this is all I had prepared for today. I expected it to take longer. Do we have questions? Or is there anything else you think we should add, Carlos and Chris?
Actually, we have like less than 10 minutes for Q&A. So it wasn't short. I mean, like, it was quite nice. Thank you, Anna. Not sure if I have anything to add. Other than I think there's some really niceties to the Sol system, personally. I really like the whole. Okay, RPMOS 3 does give you this kind of transactional history. I think it's really, really valuable that you can go to a machine and it kind of forces you to have most of it read-only, so you know that all your mutable data is contained to just like etc and var. It kind of imposes that on you, which is nice. And then all of the changes to the rest of the root disk, you have kind of this like commit by commit history. RPMOST also allows you to manipulate kernel arguments. So if you use it to do those manipulations, you have to use it to do those manipulations if you're using the bootloader setup that comes with FedoraCoreOS. You also get like those changes on a very like transactional, like logs way. And I think it's really nice to keep to control drift and to have like this standard baseline imposed. I think it promotes sanity when you have to manage hundreds of machines.
Couldn't agree more. If there's no more questions, my last comment is around the fact that we do have this install FCOS section on our documentation. It probably needs a bit of a look over for us to review, but it contains quite a few of the, it's more around installing it, and it contains quite a few detail on how to do it depending on the kind of machine you have. This is not concentrated on, so what I've installed today is on a EC2, so a VM. This is more booting on a live ISO using KVM, booting from Pixie or iPixie, booting from a container, and so on. And yeah, a bit more detail here as well. But this is all I had for today. I'm gonna stop sharing now. And thank you, Matthew and Tinax team for joining us as always. And I guess we have a few more minutes, so maybe it's a good time to, do you want to introduce Ian, who is our newest coworker? He's joined our infrastructure team, but you'll see him around more often. Okay, well, thank you everyone for coming, and we'll see you next time. Please let us know if you have any more suggestions for more sessions. If I can think of anyone, I'll let you know, Matthew. But it's hard hiring in this space. All right. Thank you, everyone. Have a nice week.
You guys, thank you, Anna.